याद है किसी को? नहीं याद किसी को?
So parallel reactions.
Parallel reaction. So what are the quantities we defined? There were some quantities we defined, right? Some things we defined. Qualitative discussion किया था ना हमने कुछ? We defined certain things. क्वांटिटी अभी करने का है, बट क्वालिटेटिव डिस्कशन में कुछ किया सोचा था हमने, किया था। नहीं याद किसी को? Okay. So let's go back and review it. Okay, so we talked about parallel reactions. Size of the reactor we have already seen in Unit 3. So we are going to focus on product distribution, how to get the desired product. Right? So we talked about parallel reactions. A goes to R goes to S, and order of reaction is A1 for first reaction and A2 for second reaction. So R of R is equal to K1 CH2 power of A1, and R of S is equal to क्या बोले? आवाज नहीं आ रहा क्या?
आ रहा है सर.
Okay. So R of S is equal to K2 into A to the power CA to the power of A2. Where A1 and A2 are order of reaction for R and S. If we take the ratio of 1 by 2, we get R of R by R of S is equal to K1 upon K2 CA to the power of A1 minus A2. And then we saw what happens, what kind of concentration we need to keep to get the desired reaction, right? And we saw that if A1 is greater than A2, we need to have high concentration of A, right? And high concentration of A is possible only if you use batch or PFR. And if A1 is less than A2, then we need to keep low concentration of A because the power is negative. So in that case, we can use mixed flow reactor. Any doubts on these concepts? And if A1 equal to A2, it doesn't really matter what reactor we choose because the mixing pattern is not really important. Then we talked about temperature. We'll see temperature in the next unit. अभी यहाँ पर ऐसे introduce किया था मैंने. And then we talked about catalyst also. Catalyst can also be used to get the desired product, but that is not in the scope of our syllabus. So mainly we are going to discuss what contacting pattern or what kind of reactor to use in which situations. Okay, so summary of qualitative discussions was reactant concentration is a key to proper control of product distribution. We use high reactant concentration for higher order reaction, that means A1 is greater than A2, and low concentration for lower order reactor, that means A1 is less than A2. And if A1 equal to A2, doesn't really matter. Then I showed you an example where we have two reactants, A and B. Instead of single reactant, if you have two reactants, A and B, then the order of reaction with respect to both A and B is important. So if A1 is for A, for formation of R, and A3 is order of reaction with respect to B for the desired product, and A2 is the order of reaction with respect to A for undesired product, and A4 is the order of reaction with respect to B for the undesired product. In that case, R of R upon R of S, the equation is this 1 and 2 again. यहाँ पर C और CB आएगा और CB भी आएगा because now it is important here. because you have two reactants. So Cb to the power of A3 and Cb to the power of A4 आएगा. And if we divide 1 by 2, we get K1 upon K2, Ca to the power of A1 minus A2, and Cb to the power of A3 minus A4. So again, what is the value of A1 and A2, order of reaction for both the desired and undesired product is important, and A3 and A4. And then we saw that if A1 minus A2, or if A1 is greater than A2, or A1 minus A2 is positive, then Ca should be high. If A1 is less than A2, or that means A1 minus A2 is negative, then Ca should be low. And if A1 minus A3 minus, yeah. And in other cases, if A3 minus A4 is positive, it means this power is positive, then concentration of B should be high. And if A3 minus A4 is negative, then concentration of B should be low. So these are the four situations. We can have any
Sir-
combination. Yeah.
सर वो रेशियो क्यों ज्यादा होना चाहिए उनका RR/RS?
Because we want R, no? Desired product is R. So rate of reaction
Yes.
of R should be always greater than rate of reaction of S, rate of formation of S.
Yes, sir.
Then only we'll get more of R, no? If R of R, rate of formation of R is more than that of R of rate of formation of S, then only we get more desired product. If it is less than rate of formation of S, then we get more of undesired product. And that's why we're taking the ratio of rate of formation of R to rate of formation of S. Okay? So these are the four situations which can arise when you have two reactants, A and B. So either it can be A should be high or A should be low, B should be high or B should be low. So it can be any combination, A high, B low, A high, B high, sorry, A high, B high, A high, B low, or A low, B high, and A low, B low. So it can be any combination. So in that case, how do we achieve that concentration of reactants A and B? That's what we also saw last time. And we said that, yeah, this is a combination. So if A1 is greater than A2, that means we need to have high concentration, right, for A, and A3 is greater than A4, then we should have high concentration for B. So both A and B concentration should be high, and then we say we take the reactor, add A and B all at one time, batch reactor. If A1 is less than A2, that means concentration of A should be low, and A3 is less than A4, that means concentration of B should be low, that means both A and B should be low. Then we add slowly. जितना रिएक्ट ऐड करेंगे उतना रिएक्ट हो जाएगा, कॉन्सेंट्रेशन यहाँ पर लो रहेगा. यहाँ पर क्या है, सब ऐड कर रहे हैं, धीरे धीरे रिएक्ट होगा तो कॉन्सेंट्रेशन हाई रहेगा, राइट. सो दिस सेमी बैच, दिस इज बैच रिएक्टर. एंड इफ A1 is greater than A2, that means A should be high, and if A3 is less than A4, then B should be low, right. So in that case we take start with A, यानी कॉन्सेंट्रेशन ज़्यादा रहेगा, एंड स्लोली भी ऐड B, दैट मीन्स B धीरे धीरे ऐड होगा, जितना भी रिएक्ट होगा ऐड होगा रिएक्ट होते जाएगा. सो B विल बी लो, A विल बी हाई. ठीक है. एनी क्वेश्चंस ऑन दिस पैटर्न्स और कॉन्टैक्टिंग पैटर्न्स दे कॉल इट, कि किस टाइप का रिएक्टर यूज़ करना चाहिए फॉर डिफरेंट सिचुएशंस. एनी क्वेश्चंस ऑन दिस डायग्राम और फिगर 6.7.1? सबको समझ में आ गया क्या? ठीक है, समझ में आ गया तो आई हैव अ क्वेश्चन. व्हाट विल हैपन if I need, say, suppose A, Ca low and Cb high? What kind of contacting pattern should I take? What should I do? I want Ca high, sorry, Ca low and Cb high.
तो B पहले कंटेनर में लेना होगा, उसके बाद
Exactly.
slowly.
In that case, what should I do? I should take B in the container and A in the add slowly. So that means we are covering all the cases, all the combinations of A and B, both high, both low, one high and one low. anything high, anything low, doesn't really matter. Okay, so this is for batch and semi-batch. Now, if you have continuous reactors, then in that case, same thing can be achieved by using, in this case, if both A and B are required high, that means A1 is greater than A2 and A3 is greater than A4. That means we can use plug flow. Both A and B are in plug flow. यहाँ पर दोनों ऐड कर रहे हैं यहाँ पर, right? And that means throughout the reactor, A and B will be high. Or we can take n number of MFR. We have seen that if we take multiple number of mixed flow reactors in series, that's equivalent to a plug flow reactor, right? So if I take 4 or 5 mixed flow reactors in series, that will be the behavior of a plug flow reactor. So I can add both A and B, and then they will go from one reactor to another reactor. So these are equivalent configurations. One is with plug flow and one is with mixed flow reactors. Okay? Any questions on this first one? Okay. Now if I want both low, A1 is less than A2 and A3 is less than A4, then what I can do is I can take a mixed flow reactor and add both basically A and B continuously. तो जैसे भी ऐड करते हैं हम, if I add the CA naught, it becomes CA. Similarly CB naught will become CB immediately. So it becomes low. And if I want one high and one low, that means A1 is greater than A2 or A3 is less than A4, then I take a PFR, whichever I want high, I put it in the plug flow, and then others I add slowly from the side, like a mixed flow reactor. Same thing I can do in terms of plug flow, mixed flow reactors. So I take mixed flow reactors in series and add B in each of the reactors. So this A becomes in plug flow and B becomes in mixed flow. Any questions? ठीक है, there are no questions. Let's do this problem. मैंने बोला था आप कर सकते हो, solve problem ही था book का. So we have example 7.1, contacting patterns for reactions in parallel. The liquid phase reaction A plus B giving R plus T, and the rate of reaction is given as dCr by dt is equal to dCt by dt. K1 Ca to the power of 1.5 and Cb to the power of 0.3. And there's an unwanted side reaction, A plus B giving S plus U, dCs by dt is equal to dCu by dt is equal to K2 Ca to the power of 0.5 and Cb to the power of 1.8. Okay, from the standpoint of favorable product distribution, order the contacting schemes of figure 7.2 from the most desirable to the least desirable. 7.2 was this one, right? ये scheme देखा था हमने, plug flow reactor, mixed flow reactor, and combination of plug flow and mixed flow reactor. Which is desirable for this particular, most desirable for this particular example, and which is least desirable for this particular example. समझ में आया problem? How many will not understood the problem? Contacting schemes are given, rate of reaction is given, we have to find out which pattern to use to get the best or maximum desired product. And this has appeared in one of the final exams. कैसे करेंगे? Any idea? Let's solve this problem. Essentially what we are doing is we are taking RR by RS, and equation 5 by equation 6. You get K1 by K2, CA to the power 1.5 है, divided by 0.5 है power, so CA to the power 1 हो जाएगा, and CB to the power of 3 न्यूमरेटर में 1.8 डिनोमिनेटर, तो यहाँ पर -1.5 हो जाएगा. दैट मीन्स यू हैव A1 is greater than A2 and A3 is less than A4. ठीक है. This power is negative and this is positive. So क्या करना पड़ेगा? which laws रखना पड़ेगा, which low रखना पड़ेगा? What should be high and what should be low?
A high, B low.
Yes, exactly. So we should keep CA high and CB low. Right? तो कैसा हो जाएगा? हमने देखा था, राइट? इफ यू वांट CA हाई, प्लग फ्लो रखना चाहिए. CB लो के लिए मिक्स फ्लो चाहिए. Right? So we take this in PFR mode, PFR mode, and this is MFR mode.
सर मगर वो PFR का कन्वर्जन लेंथ के साथ वैरी होता है, तो हम भी उसके हिसाब से ऐड कर सकते हैं, तो कन्वर्जन पे कुछ मतलब उसका इफेक्ट नहीं होगा क्या बी का?
We are talking about product distribution. We are not talking about conversion at all. मैं शुरू में बोला था, when we talk about product distribution, conversion कम भी रहेगा तो चलेगा, because you can recycle the reactants, but I don't want undesired product at all. ऐसा कुछ नहीं है मेरे को 90% कन्वर्जन चाहिए. मैं even if I get 80%, 70% conversion, I am happy with it. If I get 90% yield, याद है पीसी में किया था yield and conversion.
यस सर.
What is yield?
टोटल रिएक्ट हुआ उसमें डिजायर्ड के लिए कितना रिएक्ट हुआ.
Exactly. So if my conversion is 90% and my yield is only 50%, it's a waste of my raw material. But if my conversion is 70% and my yield is 90%, I'll be happy with that. और बहुत सारे रिएक्शन में ऐसा होता है कि conversion is hardly 10, 20, 30%, but yield is high. Because you can recycle the unreacted reactants, but जो product आएगा, जो बन जाएगा undesired, उसको waste जाता है, उसका कोई use नहीं होता है. The most important is product distribution. Conversion, अगर product distribution high कर conversion high with high yield मिलता है, high product desired product मिलता है तो अच्छी बात है. लेकिन अगर desired product कम मिलता है तो conversion high रख के कोई फायदा नहीं है. Unnecessarily I'll be spending lot of money in separation of desired product from undesired product. Distillation, extraction सब करने में मेरा time निकल जाएगा, पैसा निकल जाएगा. Whereas unreacted product I can easily recycle. And there's always a recycle in most of the reactions, most of industrial productions.
ओके सर, क्लियर.
Right? So you are not talking about conversion kitna high hai low. Now I want minimum of undesired product. Objective is that maximum of desired product. ठीक है? Okay, so in this case, if I use PFR A in the PFR mode, that will give me high concentration of A, and if I introduce B gradually along the length of the PFR, so concentration of B will be low, so I'll get the desired concentration profile of A and B, right? So this is the most desirable, right? उसके बाद क्या होगा? CA लो हो जाएगा, CB लो हो जाएगा इसमें, right? ये इसमें फिजिकल मिक्स फ्लो रिएक्टर है, अगर हम कंटिन्यूसली ऐड है तो नीचे यहाँ पर CACB हो जाएगा. ये CA0 है और यहाँ पर CACB हो जाता है इमीडिएटली. सो दिस लो हो जाता है सेकंड. और दूसरा थर्ड इज both in PFR mode, both are high, right? If you see this, why this is more desirable than this one? Suppose as I say B is more desirable than C. Why? Any logic? दोनों आर नॉट डिजायर्ड प्रोफाइल, बट लो इज बेटर देन हाई हाई. वाई?
सर वो CB के पावर में माइनस है ना.
राइट, एग्जैक्टली, एक्सलेंट. बिकॉज CB के पावर में -1.5 है, तो मैंने हाई लिया, लो लिया तो इट इज़ ओके, हाई हाई लिया तो ज़्यादा प्रॉब्लम आएगा मेरे को. So power is also important. There's the difference between A1 and A2 and A3 and A4 is also important. They're not just the value, positive or negative. Comparatively, A1 minus A2 and A3 minus A4, that value is also important. Because when you're talking about two things, you have to compare the order of magnitude. यहाँ पर order of magnitude compare करते हैं. ये powers का, A का power 1 है, B का power -1.5 है. So it is better to take low of both A and B than high of A and B. समझ में आया क्या? देवेंद्र दीक्षिता. Anybody has any questions, please ask now. This is an important concept, you should understand this. ठीक है, अगर क्वेश्चन नहीं है तो let's move on to D में क्या है? CA high है because this is in mixed flow mode and B is in PFR mode, so this is least desirable because यहाँ पर पूरा उल्टा हो गया. A high चाहिए था, A low हो गया, B low चाहिए था, B high हो गया, so totally undesirable. So that is the order of what you call desirability. A is more desirable than B, is more desirable than C and then D. ठीक है? Any questions? ठीक है, there are no questions. Let's move on to quantitative discussion now. अभी तक जो हम कर रहे थे क्वालिटेटिव कर रहे थे कि किस टाइप का फ्लो रहना चाहिए, क्या रहना चाहिए, बट दैट इज़ वन पार्ट ऑफ द सॉल्यूशन. Once we know what kind of reactor we want, then again we want to see quantitatively कितना R आएगा, कितना S आएगा. Most important is quantitative, but qualitative is desirable for configuring the reactors. Okay, so if we take a reaction, again we start with simple always. A goes to R. Then we define psi, which is called instantaneous fractional yield of R. That means at any instant, at any point in the reaction, what is the fractional yield of R? Okay, and that is defined as moles of R formed divided by moles of A reacted. So moles of R formed is DCR, because DCR is defined as and DCA is defined as CA minus CA0. Right. So that is why there is a minus here, because DCA CA minus CA, CA is less than CA0, so that is why it is minus DCA. Because R is formed and A is consumed. You can look at it that way also.
सर तो वो 1 हो जाएगा ना साई?
1 कैसे होगा रे?
क्योंकि सर A गिव्स R है ना, तो जितना R फॉर्म होगा उतना ये रिएक्ट होगा ना.
नहीं, हमने यहाँ से नहीं बोला एलिमेंट्री रिएक्शन. We never said it's elementary reaction.
यस सर.
Always think about that. We never mentioned in all these discussions, अभी जितना भी किया है qualitative बोलो या अभी जो quantitative कर रहे हैं, we never talked about elementary reaction. We talked about reaction and we always talk about order A1, A2, A3, A4. हमने कहीं नहीं बोला कि elementary reaction है. ठीक है?
यस सर.
Okay, so fraction of A reacting at any instant which is converted to desired product. That is what psi is called, and we pronounce it as psi. Okay. So psi is a function of A, concentration of A. Since A changes throughout the reactor, actually ये plug flow के लिए रहता है ये, but ठीक है, mixed flow के लिए उन्होंने general define किया है. Psi will also change position in the reactor because position in the reactor is for only plug flow reactor. Mixed flow में same रहता है, but ठीक है, उन्होंने ले लिया ऐसा definition के लिए. And then we define another term which is called phi. ओवरऑल फ्रैक्शनल हीट, ओवरऑल मीन्स टोटल पूरे रिएक्शन में, इंस्टेंटेनियस मीन्स कहीं भी एक टाइम पर क्या रिएक्ट कन्वर्शन होता है, whereas overall is when I take, suppose I take a reactor, any reactor, right, plug full लिया या mix हो लिया, if I take any reactor, overall is comparing input and output, यानी मेरा exit पर कितना आया फ्रैक्शनल हीट, whereas instantaneous is at any point in the reactor. जैसे यहाँ पर बोला इसने, यहाँ पर कितना है, यहाँ पर कितना है, यहाँ पर कितना है, यहाँ पर कितना है, वैसे यहाँ पर मिक्स फ्लो में बोला, बट मिक्स फ्लो में इतना कुछ नहीं रहता है, मिक्स फ्लो में चेंज नहीं होता है, इट्स नॉट सपोज टू चेंज इन मिक्स फ्लो बिकॉज concentration supposed to be same throughout the reactor, right? But इन्होंने वो concept extend किया है, so if I take mixed flow reactor, कहीं भी what is the instantaneous, what is the value of psi or dCr by minus dCa. So this is instantaneous value, whereas what you say overall, overall means compared to outlet, inlet outlet में कितना है, that is overall, पूरे जैसे फीड से बाहर प्रोडक्ट आया तो कितना मेरा yield मिलता है, right? So fractional yield, fraction of all the treated A that has been converted to R, जितना भी यहाँ पर react हो गया A, total कितना R form होगा, and that is essentially the mean of instantaneous fractional yield at all points in the reactor. जब यहाँ पर point है, यहाँ पर point है, यहाँ पर point है, इसका जो mean रहेगा वो यहाँ पर total आएगा, right? So this is mean value, this is instantaneous value. ठीक है, डिफरेंस समझ में आ रहा है मीन और इंस्टेंटेनियस के? अगर कॉन्सेंट्रेशन सब जगह सेम नहीं रहा मिक्स फ्लो रिएक्टर में तो अलग अलग हो सकता है, assumption is that is always same, but it's not always the same. So instantaneous is any point in the reactor, whereas overall is at the exit to the reactor. So phi is defined as all R form, जितना भी फॉर्म हुआ टोटल रिएक्टर के एग्जिट तक, डिवाइड बाय ऑल ए रिएक्टेड, जितना भी R फॉर्म हुआ है CRF, बिकॉज CR 0 माइनस 0 लिया है, CR 0 इक्वल टू 0 लिया हमने, राइट? So CR फाइनल minus 0 upon CA0 minus CF, and that we can write as CRF upon minus delta CA, because delta CA is CAF minus CA0. ठीक है, and that is why we are writing this as bar, that is mean. ठीक है, so we are saying कि phi is nothing but mean of instantaneous fractional yield, जितना भी instantaneous yield है at different points in the reactor, उसका अगर mean लिया तो we should get phi, overall fractional yield. Any doubts, questions on these two definitions before we proceed further? Psi and phi. ठीक है, कोई क्वेश्चन नहीं है तो लेट्स प्रोसीड फर्दर. Okay. So the overall fractional yield represents the product distribution of at reactor outlet, whereas instantaneous is in the reactor at any point. So proper averaging of psi depends on type of flow in the reactor. Mixed flow है कि plug flow है. PFR we know that CA changes progressively throughout the reactor. We have seen that. Right? If I take a PFR, then my concentration profile is something like this. So concentration value is different throughout the reactor. So psi is we have defined that dCr upon minus dCA, and phi p, that means for plug flow reactor, value of phi is CRF upon CA0 minus CF, ऊपर define किया था, और CRF upon minus delta CA. So now we need to find the relation between psi and phi for plug flow reactor. So what we do is integrate this. इसको लिया हमने dCr, integrate from initial time t equal to 0 to time t, so CR0 to CRF, और उधर लेके आए माइनस, हम ये इधर लेके आए माइनस dCA, तो माइनस हो जाएगा psi into dCA integral from CA0 to CF. So if we integrate this, we'll get CRF minus CR0 is equal to minus integral CA0 to CF psi into dCA. Any questions on equation 5? Okay. So if CA0 is equal to 0, that becomes CRF. So we substitute 5 in 4, this equation 4, the definition of capital phi का. We put CRF का value यहाँ substitute करेंगे हम, and what we'll get is phi p, तो यहाँ पर था phi p is equal to CRF डाला हमने, माइनस ये नीचे था डिनोमिनेटर CA0 माइनस CAF, माइनस यहाँ से आया, 1 upon CA0 minus CF integral CA0 to CF psi into dCA. So that's the relation between instantaneous fractional yield and overall fractional yield for a plug flow reactor. Any questions? Okay, so we can write this as phi p is equal to 1 upon delta CA. Delta CA is nothing but CF minus C0, so the minus C0 निकल जाएगा, integral CA0 to CF psi into dCA. And we'll be using this in many of the calculations. Examples जो solve करेंगे, we'll use equation 7 for calculating the value of CR or CRF. ठीक है. So now mixed flow reactor लिया, ये plug flow के लिए mixed flow के लिए concentration में FR is CA throughout the reactor. This is for ideal reactor. That means psi is the same throughout the reactor. Right? अगर mixing बराबर है, perfect mixing है, तो CA concentration has to be same throughout the reactor. Right? So everywhere concentration has to be same. So value of psi has to be same, and that will be the overall value of overall fractional yield. That is phi for a mixed flow reactor is equal to psi for mixed flow reactor. Any questions? Okay. नहीं है तो फिर let's see, for any reactor we know that phi is equal to all of whatever is R form, total R form upon total A reacted, CRF upon CA0 minus CF is summary, and CRF is equal to phi into CA0 minus CF. So if you know the value of phi, if you can find the value of phi, we can find the value of CRF for any reactor. Of course CF का value चाहिए हमारे को, but phi का value is important, so we need to find the value of phi for PFR बोलो या mixed flow reactor बोलो, then we can find what is the value of desired constant and what is the concentration of desired product. Okay. If there are no questions, let's proceed further. Now if you look at this figure 7.3, we are plotting psi, this is instantaneous fractional yield. on the y-axis, and we are plotting against concentration of A, right? So for plug flow reactor, the curve is given by equation 13 and 9 बोलता है. Let's see what is equation 13 and 9. Yeah, यही जो दिया है यहाँ पर. This 13. CR is equal to 5 into CA naught minus CF. This is 13 for 11 spill. And 9 is nothing but this usual equation 5. Okay, so ये दो इसको वैल्यू इसकी वैल्यू पे डिफाइन करता है कर्व. So this is the type of curve you get for a plug flow reactor. Next flow reactor again 13 and 10. 10 में जो था 10 was what? 10 was this. So this is, let me say, let me put this as 13. 13. This was 9. And this was 10. Yeah. So ये equation देते हैं. So they have plotted this thing, psi versus C plot किया. So this kind of curve you get for mixed flow reactor. Okay. Now if you look at CRF, what is trying to find out is the value of CRF, right? CRF जो है, if you see this, if you see this equation 13 or 9 here, CRF is nothing but phi into CA naught minus CF, right? So if I take okay, so if you look at equation 9 is what? Phi P is equal to CA naught to CF psi DC, right? So if I am plotting this psi value, this is the value of psi versus this is delta C, right? So psi into DC, right? Means integrate किया psi को between CA naught to CF. That means if you find this area under the curve, right? Psi versus CA. So this is the area of the under the curve. That will give what? Phi P into delta C, right? समझ में आ रहा है? ठीक है. So if I plot psi versus CA and find the area under the curve between CA naught to CF, I'll get phi P into delta C from this equation. That's what he has done here. Psi versus CA integrate किया, that means area under the curve between CA naught to CF किया, निकाला तो what you'll get is phi P into delta CA. Phi P into delta CA क्या है? CRF. ठीक है, समझ में आया? एनी क्वेश्चंस? कैन यू हियर मी?
हाँ सर.
Right. So this is essentially equation 9 is nothing but 5p into delta CA, or this is 5p into delta C, area under the curve. This is the value of CRF for a plug flow reactor. Mixed flow reactor में क्या रहता है? Phi is not phi cap nothing but psi, right? So that means at the exit ये जो है CF है, right? This CF value and this CA0 value. So at this point जो रहेगा ये point, this psi value, right? And what you'll get is this for all reactors. Mixed flow reactor लिखा रहेगा CRF is equal to psi into delta CA. Right, because phi is equal to psi for mixed flow reactor and delta CA. Okay, so in this case you have to take what do you take? The rectangle area जो पहले देखा था हमने mixed flow reactor you never take area under the curve, you always take rectangle area at CF, that is final concentration of which is in the mixed flow reactor जो concentration रहता है. So you see this is the value of CRF in a mixed flow reactor, whereas plug flow reactor में high है, mixed flow reactor में कम है. डिफरेंस समझ में आया मिक्स फ्लो रिएक्टर एंड प्लग फ्लो रिएक्टर का? In mixed flow, we always take area of the rectangle when we plot y versus delta c और psi versus delta c है. तो यहाँ पर जो रहेगा एरिया अंडर द कर्व नहीं लेना पड़ेगा, यहाँ पर एरिया अंडर द कर्व लेंगे तो यहाँ पर वैल्यू हाई जहाँ आएगा हरदम यहाँ पर कम ही आएगा. एंड इफ यू स्टेज दैट मीन्स वी आर टॉकिंग अबाउट n mixed flow reactors. We take n number of mixed flow reactors in series. तो ऐसा एरिया अंडर द कर्व डिपेंडिंग ऑन क्या है कॉन्सेंट्रेशन एट ईच रिएक्टर. सपोज इस रिएक्टर 1 ये सी ए नॉट है तो रिएक्टर 1 रहेगा, ये सेकंड रिएक्टर रहेगा, ये थर्ड रिएक्टर रहेगा. सो फर्स्ट रिएक्टर में इट इज गोइंग फ्रॉम सी ए नॉट टू सी ए 1, तो ये एरिया अंडर द कर्व आएगा. सेकंड रिएक्टर में इट इज गोइंग फ्रॉम सी ए 1 टू सी ए 2, तो ये एरिया अंडर द कर्व आएगा. थर्ड रिएक्टर में सी ए 2 टू सी ए, तो ये रहेगा. सो नाउ इफ यू इंक्रीज द नंबर ऑफ रिएक्टर्स तो ये थोड़ा और कम हो जाएगा, यहाँ पर आ जाएगा, राइट. सपोज आई पुट नो मोर रिएक्टर्स, जैसे यहाँ तक आएगा तो ये एरिया और बढ़ते जाएगा as I increase the number of reactors. So if I increase the number of reactors, it will approach the plug flow behavior. समझ में आया ये? कितने लोग को नहीं समझ में आया? रेज योर हैंड. ओके, सबको समझ में आया तो बहुत अच्छी बात है. ओके, देन नेक्स्ट वन इज कॉन्टैक्टिंग पैटर्न विद द लार्जेस्ट एरिया प्रोड्यूसेस मोस्ट आर. ये देखा हमने, राइट. यहाँ पर मैक्सिमम आर आएगा एरिया अंडर द कर्व या रेक्टेंगल विच केस द मैक्सिमम आर. तो मैक्सिमम आर चाहिए तो ये पी एफ आर लेना चाहिए, या फिर नंबर ऑफ मिक्स फ्लो रिएक्टर्स लेना चाहिए, या फिर बाद में लीस्ट आएगा मिक्स फ्लो रिएक्टर. प्लग फ्लो इज द बेस्ट एंड इट डिपेंड्स ऑन द साइकिल, राइट. कॉन्टैक्टिंग पैटर्न जो रहेगा उस पर डिपेंड करेगा. दैट्स व्हाट इट सेज हियर, राइट. इन दिस केस प्लग फ्लो जो कर रहा है, प्लग फ्लो कर रहा है, ये मिक्स फ्लो में कम होते जाता है. मिक्स फ्लो अप टू CA1 and plug flow after that. So it depends on the type of contacting pattern, kind of concentration वगैरह. बट ये हम देखेंगे ये जस्ट अंडरस्टैंडिंग के लिए, डोंट वरी अबाउट दिस थिंग, ये सिर्फ अंडरस्टैंडिंग के लिए. अल्टीमेटली वी आर गोइंग टू यूज दिस थिंग ओनली फॉर ऑल आवर कैलकुलेशंस. ग्राफिकल नहीं करने वाले हम, न्यूमेरिकली करने वाले. वी आर गोइंग टू यूज फाइंड द वैल्यू ऑफ फाइव, देन बेस्ड ऑन द वैल्यू ऑफ फाइव वी आर गोइंग टू कैलकुलेट व्हाट इज द वैल्यू ऑफ concentration of desired product. This was just explaining कि कौन सा अच्छा रहेगा. ठीक है
सर एक डाउट था सर.
बोलो.
सर वो लास्ट 3 ग्राफ्स में कुछ जगह पे हमने एरिया अंडर द कर्व लिया और कुछ जगह पे मतलब पूरा ऐसा एरिया ऑफ रेक्टेंगल लिया, तो फिर वैसे क्यों किया है?
मिक्स फ्लो में ऑलवेज रेक्टेंगल रहता है.
बट सर हमें एरिया मैक्सिमाइज करना है ना, तो फिर
नहीं.
अभी
अंडरस्टैंड, मिक्स फ्लो रिएक्टर में what happens in mixed flow reactor? What happens in mixed flow reactor? What is in you are forgetting what is plug flow reactor, what is mixed flow reactor.
सर
Just maximize area नहीं है, that is not the objective. Objective is you have to use the proper behavior of the reactor and then get the area under area relevant area. Oh, because it's PDF का copy किया मैंने इसलिए नहीं दे रहा वो. Okay. Let's see. The mixed flow reactor में always if you take CA naught here, if you take CA naught here, it immediately becomes CA. ये पहले बताया था मैंने आपको. So concentration in the reaction minus RR, RA और plus RR के CA रहता है to the power of A1, right? So this is the concentration which is used for rate of reaction in a mixed flow reactor. Plug flow reactor में it is different. That's the concentration profile in plug flow reactor, right? Same apply किया तो concentration is different in each point in the reactor, and that is why the reaction is higher, rate of reaction is higher here than at here. तो ज़्यादा यहाँ पर फॉर्म होगा और धीरे धीरे कम होकर ये this is the value of CA, this is the mixed flow reactor concentration. So always in the plug flow reactor rate of reaction is going to be higher than mixed flow reactor, and that is why we take integral for plug flow reactor. शुरू में पता है यूनिट 2 में, right? तो यूनिट 3 में we take always integral for plug flow reactor and rectangle for mixed flow reactor. याद आ रहा है विराज?
यस सर.
Right, so the concept is fundamental concept कहीं change होने वाला है. Whether I mix flow or plug flow together, plug flow mix flow together, doesn't really matter. If I want to find what is the area under area of relevant area, एक केस में मेरे को area under the curve लेने का है, सेकंड केस में मेरे को rectangle का area ही लेना है. Definition of plug flow mix flow doesn't change. Underlying principle doesn't change. यहाँ पर इंटीग्रल नहीं रहता है, नो इंटीग्रल. ये डिफरेंस याद रहना चाहिए आपको.
बट सर एक बार वो ग्राफ डिस्प्ले कर सकते हैं आप? सर उसमें उन्होंने फर्स्ट MFR यूज किया है, फिर PFR यूज किया है, मतलब
हाँ MFR है,
एरिया.
ये MFR है, ये PFR है.
ये सर नीचे वाला, उसके नीचे वाला ग्राफ.
हाँ
सर तो फिर फर्स्ट उन्होंने MFR यूज किया, तो फिर वहाँ पे एरिया ज्यादा होगा ना एरिया अंडर द कर्व के वजह से, मतलब वो एक्स्ट्रा कवर कर रहा है ना कर्व के बाद, तो वैसे ही दूसरे साइड पे मैं फर्क यूज कर सकते हैं ना, सो फिर CRF मैक्सिमम होगा।
See, it all depends on rate of reaction also, right? A1 क्या है, A2 क्या, हमने देखा qualitative discussion, right? He is just giving situations के कब क्या कर सकते हैं. Yes, you can try that. You are saying this ना, यहाँ पर MFR use किया था.
यस सर, यस सर।
You are saying this is possible. It is possible, yes. यहाँ
सो
पर
मतलब
देखो
ये सर सिर्फ एग्जांपल्स है क्या?
एग्जाम्पल्स है ना, ये जस्ट गिविंग एग्जाम्पल्स कि क्या हो सकता है इन सिचुएशंस. इफ यू टेक प्लग फ्लो रिएक्टर ओनली, यहाँ पर जो लिया है ये प्लग फ्लो लिया, राइट? अगर ये प्लग फ्लो, ये प्लग फ्लो है, सी ये दिस एरिया इज प्लग फ्लो एरिया, दिस एरिया इज मिक्स फ्लो एरिया, राइट? सेम इसके लिए, सेम रिएक्शन के लिए मैंने प्लग फ्लो लिया तो इतना आएगा CR, और मैंने मिक्स फ्लो लिया तो ये, बिकॉज दिस CRF फाइनल कॉन्सेंट्रेशन, राइट? तो ये एरिया आएगा मेरा मिक्स फ्लो के लिए, प्लग फ्लो के लिए एरिया आएगा पूरा, राइट? सो डिपेंड्स ऑन द कर्व यू गेट, देन यू कैन डिसाइड कि क्या रिस्क करने का है, राइट? जैसे यहाँ पर लिया हमने, राइट? प्लग फ्लो का एरिया इतना ही है, मिक्स फ्लो का एरिया इतना पूरा, अगर ये लिया हमने तो यहाँ पर ज़्यादा है, समझ रहे हैं? तो इट डिपेंड्स ऑन व्हाट काइंड ऑफ कर्व यू गेट. ये जो ये कर्व है ये डिफरेंट है, राइट? अगेन यू आर प्लॉटिंग साई वर्सेस CA. You can get different curve depending on the reaction order, yeah, depending on the data. ये कर्व डिफरेंट है, ये कर्व डिफरेंट है, ये कर्व डिफरेंट है, राइट? यहाँ पर कम बढ़ के कम हो रहा है. डिपेंडिंग ऑन द टाइप ऑफ डेटा, डिपेंडिंग ऑन द टाइप ऑफ रिएक्शन, डिपेंडिंग ऑर्डर ऑफ रिएक्शन, यू कैन मिक्स, यू कैन यूज मिक्स फ्लो रिएक्टर. इस केस मिक्स फ्लो इज बेस्ट, राइट? इस केस में प्लग फ्लो इज बेस्ट. इस केस में इट कुड बी मिक्स फ्लो प्लग फ्लो कॉम्बिनेशन, और बोथ मिक्स फ्लो. डिपेंडिंग ऑन द टाइप ऑफ कर्व, साई वर्सेस concentration, then you decide कि क्या यूज करने का.
यस सर।
He's just giving examples क्या हो सकता है. It's not really a particular problem कि हरदम ऐसे रहेगा. No, it will depend on many factors. It will depend on rate of reaction, order क्या है, with respect to A क्या है, B क्या है. So many factors are there which you already seen. So this is just giving concepts कि क्या हो सकता है. It can be anything. It can be mixed flow, it can be plug flow, it can be plug flow mixed flow combination. That's what he's saying. यहाँ पर plug flow अच्छा है, यहाँ पर mixed flow अच्छा है, यहाँ पर he's saying कि maybe plug flow mixed flow combination is better.
यस सर, गॉट इट। यस सर।
Remove all this confusing रहेगा सबके लिए. ठीक है, ये टाइम हो गया तो नेक्स्ट टाइम विल डिस्कस अगेन दिस सॉल्व प्रॉब्लम है. ये भी फाइनल एग्जाम में आया है. सो इस केस में दो सॉल्व एग्जाम्पल, दो थे अपेयर्ड इन द फाइनल एग्जाम. वेरी स्ट्रेंज, बट ठीक है, विल डिस्कस इट. दीज आर गुड एग्जाम्पल्स. नेक्स्ट टाइम विल लुक एट एग्जाम्पल 7.2. ठीक है, एनी अदर क्वेश्चंस और कमेंट्स?